Hello everyone, back to this tutorial about teleoperation and Mujoko. And if you can see from that picture, this is about Pinocchio. This is not about Pinocchio, but it sort of relates to that. Like if you go to a puppet show, you usually have this hand or the puppet master and you have wires that are connected to, in this case, an arm. And what I noticed looking online at various tutorials is that you have two robots. Usually you have the remote one and the follower and the leader, and essentially they copy each other, so the follower copy the leader, and if you are tired and you leave your hand, the leader will flop down due to gravity and the follower is just to copy that movement. If you're doing this for several hours, this is quite annoying because you get tired and you want to maybe pause and go back. But currently, most of the, well, at least the software I've seen, doesn't really have this modality where you want to freeze your arm in position and maybe go back to the same position again. So the solution is quite simple. I've been playing with Mujoko Swan or MJ Swan, which is essentially a web version of Mujoko. It's developed by a good friend of mine on x.com. You can find the link below. And I essentially deployed the SO101 arm. The green one is the leader, the yellow one is the follower. So I made a very simple simulation where you can move the leader, the green one, and the yellow one will follow. So I'm moving the actual joints. Okay. And everything is fine. You can see the difference on the top. In reality, there will be lag, so if you're not careful, what you see might have a small lag or a big lag, so it depends on what kind of protocol you're using. What happens if I go in reality mode? You have gravity, and you have my arm or hand pulling, like, moving, effectively the leader, and the follower is essentially copying my movement by simply transmitting the joint position. So it's essentially cloning my behavior. If I leave my hand, this thing is going to gradually fall down due to gravity, inertia, etc., and your gear ratio. So usually, if you have a high gear ratio in your motors, this is quite annoying because you will feel the resistance of the arm, and it's uncomfortable, but it will slowly move to the ground. On the other hand, if you have a low gear ratio, it's more soft, easy to move, but it will flop down very quickly when you leave it. So one solution to avoid this is very simple. You can introduce a PD control on the joints. You can essentially say, hey, when I press this button, maybe there's a button on the gripper, freeze my current position, which means then the follower will do the same thing. So in this simulation, if you press H, it's going to go into lock mode, right? And as you can see now, when I do any movement, it's going to stay in place, when I leave my my hand. So if I do that, so I'm going to remove it, yeah, and then I'm going to memorize it and it stay in place. And this is a very simple, elegant solution which you can implement in real hardware. And in the next tutorial, I'm going to actually apply it into an L robot setup where I have a leader and a follower. And I'm going to play with different modalities, maybe a hard lock where he's going to do his best, like to stay static, and maybe one will be like a softer lock, so you can move it and boomers move and maybe remember different position. So I hope you enjoyed and think about this very simple problem, which is a very nice solution, and I hope it helps you in your daily teleoperation. Thank you for listening and see you very soon.